So, coral reefs as a habitat are pretty exciting. Some people consider them to be the rainforests of the sea, but they're actually much more diverse and way more productive than the rainforests. Coral reefs only cover about 1% of the ocean floor, and the ocean covers about 75% of the earth, so it's a very, very, very small fraction of the earth that actually is coral reef. But over 25% of marine species depend on coral reefs at some point in their life, whether it's for reproduction or for food or whatever. So it's a very, very important environment, although it's only a small space. In the coral reefs you can find over 4,000 different species of fish. That's out of about 30,000 species described worldwide, including all the ones in the ice and in the rivers and in footprints from hippos or whatever. So it's a pretty big fraction lives on the reefs. And then about 700 species of coral worldwide, with 70 reef-building species found here in Hawaii. A lot of those species are only found in the northwestern Hawaiian Islands. The water temperature between there and here is great enough that we see different types of coral reef. On these islands, there's roughly 20 or so that you'll see on a regular basis, although I'm not sure how many have been spotted. Then within 200 miles of shoreline of Hawaii, there's over almost 1,200 species of fish. I got that number from NOAA. And I don't know what fish they're looking at, because I certainly haven't seen that many kinds, but they even say that there's about 550 species of nearshore fish, so that would probably mean anything within about 3 miles of shore. So the reefs in Hawaii have sort of a cool life history. So they all go through the same sort of progression from birth to death. And what happens is you get this new island pops up out of the ocean, for example, this island. And it's got some pretty steep shoreline. So because corals can only live between 0 and 300 feet, the corals will colonize the edge but won't be spread out very far. And you get what's called a fringing reef because it's just on the fringe of the island. As the island gets older, it will erode and weather away. Another process that happens here in Hawaii that brings the islands lower is actually the cooling of the crust. As it moves away from the hot spot, it contracts and it pulls the islands down with it. That's, for example, well, I guess that's for another thing is this island is actually so massive that it puts so much pressure on the crust that Maui is actually sunk down in a hole that the Big Island has created. And then Oahu, just past that, is on the bulge on the outside of that. So if you think about dropping a pebble in a pond, if you freeze it just as it hits the surface, you'll see this kind of a bowl shape with a little bulge on the outside, and that's exactly what's happening around here. And that's why we have these big coral flats on Oahu that are up either out of the water or right at water level. So all these islands in the main Hawaiian Islands all have these fringing reefs. But as you go farther northwest, you'll start to find barrier reefs around some of the islands. So what's happening is, although the island is shrinking, the reef is continuing to grow and stay near the surface. And at that point, it's actually trapping sediments that allow plant life to grow. So you might see naupaka or coconut or whatever on those islands. And then eventually, the island will subside completely beneath the surface of the ocean, and then you're left with just the coral reef around, and that's called an atoll. And then beyond that, the reefs will be so far north that it's too cold for them to survive. They'll die, they'll start to break down, and then you'll just be left with a seamount. And those seamounts, you can follow the dots all the way up the plate, all the way to the Aleutian chain where they're being subducted underneath that plate. So there's a little animation here. This just kind of shows the reef in pink growing as the island is subsiding, and showing you how the atoll is formed from what we have here. And I want to thank the author of this thing for coloring it like a watermelon, because every time I see this I get hungry and thirsty. Okay, so Why are corals important at all? Why do we need corals? For the fish, they need the corals for shelter. So the corals, as they grow, they provide the structure of the reef. They make all these little cracks and crevices and caves and all that. You go stick your head down under a coral column, you'll find all types of shrimp and all types of little mimpachi, the little red fish. You'll find butterfly fish, cleaner wrasses, whatever. On top and inside all the little finger corals, you'll find angelfish and juvenile tangs and juveniles and parrotfish and all sorts of cool stuff. They really depend on that structure to avoid predation from bigger fish. Other animals use, or other fish use the reef for nest sites, so they'll lay their eggs in a little pocket and they'll guard it. Certain fish like the Hawaiian gregory, it's a little damselfish, it's gray, it's got a yellow eye, I'm sure you've seen it if you've been in the water. They will actually take the coral and they'll pick away parts of it and start a little algae farm. And you'll have these little turf algae growing, and then they'll pick away the algae that they don't like to eat and spit it out and grow all the stuff that they do like to eat, which becomes a great food source for other types of fish that come in huge numbers and raid the farm and chase the little gregory away and eat that. And then beyond that, you know, like for example, if that school of fish that comes in and chases the gregory away and eats his farm is yellow tangs, you might see yellow trumpetfish following them, you know, waiting to pick a snack out from outside the school. So not only shelter, but also for food and as a nest site. So the coral reef environment, all the fish that we have here depend on that. Even though they eat, a lot of them eat algae, the types of algae that you find in a coral reef environment are different than the types of algae you would find if we lost our corals. So here with the coral reef you see a lot of the turf algae, but if we lost the coral you would find a lot of macroalgae, which the small fish will not eat. So we definitely need to have that in balance. So corals being the reef builders, I've explained many reasons why that's important. This carbon sink concept here, so you know the calcium carbonate, that carbonate part of it has a nice carbon atom in there, and you know, forget what humans may have done, but just the way the world works is there's sources for carbon dioxide in the air, being like fires or respiration or whatever, and then there's sinks, being like the growth of a forest or the way oil is produced. Phytoplankton in the water uses sunlight, they trap carbon and they die and they sink to the bottom, and that's how all that carbon got there. But the reefs are a carbon sink, so they're a place where carbon is stored for long periods of time. And as a wave break, that's valuable. On this island, it's not so relevant per se, because our shorelines are very exposed and do get a lot of wave action. But farther up the chain, you'll find places where there's reefs, a little bit farther out, and then white sandy beaches inside. And without that reef, those waves will come right in, grab the sand, and suck it right out. So other nations, other South Pacific islands, if they didn't have their reef, one storm could just wash the whole island away. So it's very important that they have the reefs too. Basically what's happening is you got this wave coming in, and it feels the bottom as it gets into shallower water. And when it trips over the reef, a lot of the energy is dissipated. And so you'll still have waves, but they won't be as big as they would be if they were just crashing on shore from the open ocean. For resources, that's a very general term. You know, it could be to collect shells to sell them if that's what you like to do. It could be for fish, for food, or whatever. You know, a lot of places the people do depend on the food they get from the reef. Tourism, that's pretty much the moneymaker for corals. You know, everybody that comes to Hawaii, maybe not everybody, but a significant portion of the people who come to Hawaii want to see our coral reefs. If we don't have good reefs, they aren't going to come here. They're going to go somewhere else, like Indonesia or Palmyra or whatever has a pretty reef. So that's one reason. That's one reason the government supports efforts like this, like HTA, the Hawaii Tourism Authority. They've given us funding at Reef Teach to support this, so that that reef, Papalu, will remain a tourist attraction. Do you guys, so you were talking, you guys did like a human use survey. How many people come to Puaco Road, any of these access sites that are just tourists that want to snorkel. Do you have that number off the top of your head?
James and Nate.
Not off the top of my head. You were talking about percentage?
Yeah, roughly. Yeah, or a number.
I'm gonna think about money now.
Yeah.
I would say people that just live here and enjoy that space more than likely account for about 2/3.
Okay.
Maybe a little more, and then about 1/3 of that are people that are visiting here.
Okay, cool. So it's a significant portion even for you guys, and then Wailea Bay for sure is going to be more than 2/3 tourism. So yeah, that's one reason we want to have good corals. And then these last 2 points, medicine. There's a lot of promise in cancer treatments with certain types of corals because they do produce some pretty gnarly chemicals used for defense from other diseases. Corals actually fight one another for space, so if you ever see 2 coral colonies close together, you'll always see a small space in between them where there's a lot of sort of dead-looking tissue, and that's because at night they reach out with their tentacles and actually sting and eat the polyps on the other side, trying to take over that space. In terms of culture, the Kumulipo, the Hawaiian creation chant, the coral polyp is the first living organism that's mentioned in that creation chant, and that sort of shows 2 different understandings, and one being that the coral is the basis of the reef environment and therefore of food, so they realized how important it was. But beyond that, it was the coral that settled and created a marine environment that allowed birds and stuff to support and bring nutrients up to the land and let all the other things come here. So it probably wasn't coral that was here first, but it was probably coral that set up the first productive system that all the other things are built upon. Okay, so I just like these pictures because this shows, butterfly fish actually eating the coral polyps, and then the omilu or the bluefin trevally cruising the reef looking for a snack. But if we have good coral structure, you might not be too lucky. Obviously, he's a big fish. Obviously, he gets lucky enough that he can grow. Different growth forms. So here in Hawaii. Our corals are not as, at least in the main islands, are not as elaborate as you can find in the South Pacific or even the northwestern Hawaiian Islands, where you get these big plates and branches that grow way out and have all these little spaces underneath. But we do have big mounding corals, or sometimes called the massive growth form. We have some branching corals, like the cauliflower corals here. We have over here, can you guys read these little words on the top? So on the left to right it says plate-like, foliaceous, columnar, massive, and then branching. And on the bottom you have encrusting and free-living. So free-living, like the mushroom corals. Encrusting would be like a lot of the rice corals that you see, the little brown ones that grow just right across the bottom. But the rice corals can also form plate-like structures. They can also form foliaceous, so kind of like rose petal almost. Columnar would be like finger corals, and then branching would be like the rice corals, the lace corals, not the rice corals, the cauliflower corals, or the lace corals, or the antler corals, stuff like that. Okay, so you have some examples there.